Right. Welcome back. There, muted the YouTube feed. Right, yeah. Welcome back. Don't have a lot of time to do this one. Guess I have Christmas stuff going on. So let's just jump right into it. Dumbo octopus. You enter a large cavern full of rare bioluminescent Dumbo octopuses. Oh wait, they're an actual thing. Ah, it's an octopus with ears. Okay. That's amazing. They seem to not like the Christmas lights on your submarine. Why do we have Christmas? Well, I guess it's Santa Claus's submarine. So you turn them off for now. It's probably a good idea. There are 100 octopuses arranged neatly in a 10 by 10 grid. Each octopus slowly gains energy over time and flashes brightly for a moment when its energy is full. Although your lights are off, maybe you could navigate through the cave without disturbing the octopuses if you could predict when the flashes of light will happen. Octopi. No, it's not octopi. Octopi would be the plural if octopus was Greek, I believe, but it's... No, if it was Latin, but octopus is Greek, so it should be an octopode when they're multiple. And that's why octopus is still accepted. Or something like that. Right. Sorry, I just got octopi in the background here. Each octopus has an energy level. Your submarine can remotely measure the energy level of each octopus, which is my puzzle input. So this is an example input of the energy levels of all the octopuses. The energy level of each octopus is a value between 0 and 9. Here, top left octopus has an energy level of 5. The bottom right has an energy level of 6, and so on. You can model the energy levels and flashes of light in steps. During a single step, the following occurs. First, the energy level of each octopus increases by 1. Then, any octopus with an energy level greater than 9 flashes. This increases the energy level of all adjacent octopuses by 1, including octopuses that are diagonally adjacent. Right, so all sort of 8 around it. If this causes an octopus to have an energy level greater than 9, it also flashes. This process continues as long as new octopuses keep having their energy level increased beyond 9. An octopus can only flash at most once per step. Right. Finally, any octopus that flashed during this step has its energy level set to 0, as it used all of its energy to flash. But what happens... So wait, if, let's say this went to a 9 and then to a 10, or it flashes, then that becomes 0, and all of these become 1 higher. That would make this also flash. Would this then have a 1? Or would it still be a 0? Adjacent flashes can cause an octopus to flash on a step, even if it begins that step with very little energy. Consider the middle octopus as 1 energy in this situation. So 1 surrounded by 9s. After step 1, all of these, right, so they're set to 0. So all of these flash, and this one now gets an energy level because all of the ones around it make this go high enough that it also flashes. Right. After step 2, this happens. An octopus is highlighted when it flashed during the given step. Wait, I got a notification from a different channel. Right. Here's how the larger example above progresses. So all of them increase by 1, all of them increase by 1 again, and then we have some flashes, and again, and again, and so on and so forth. After step 10, there have been a total of 204 flashes. Fast forwarding here is the same configuration every 10 step. So it goes through that. After 100 steps, there have been a total of 1,656 flashes. Giving the starting energy levels of the Dumbo octopuses in your cavern, simulate 100 steps. How many total flashes are there after 100 steps? So you can grab our test input, which is for once the same size as our example input, which is interesting. Of course, we're still gonna grab the example input because then we can look at this and we can look at, like, simulate the steps and see that we're doing it right. So we want our example input there, and then we want to start coding in part 1.nym. I'm not sure if I'm going to be able to do both parts because of my time constraint. Oh, someone on YouTube said, "LOL, I'm literally doing AoC day 11 right now." So yeah, I guess spoiler alert, massive spoiler alert. Right, so what would this be before? So I'm thinking, well, we can update. Okay, so let's just first do this. Octopuses is equal to just read the data in input example.txt. I'm not sure if we're gonna even bother to convert this into anything else. Octopuses. So for I in, we're just gonna do one step right now. Again, in nym this is inclusive, so this will run the 0th step. So we're gonna do for row in, well, we want to get the position because we want to do we want to be able to go to different positions. So we do for row in 0 ... I guess we can hard code this. Again, I don't have a lot of time, and the input and our input example is the same size. So it is a 10 by 10 grid. So we do for row in 0 all the way up to 9, and for column in 0.9, then we do I guess we can do, I think we want to call a procedure here. So add energy to row column, and then we write a procedure up here called add energy, which takes in an x and y, takes in a row and a column. Those are integers and doesn't return anything. It's just going to mutate the data. And now octopuses, and this is going to be, well, now we have row and column. I think I'm going to go, let's just do x, y. Oops. X, y, X, Y, X, Y. And now this is a string. So each string is 10 characters long plus a new line. So if we go to x plus y times 10, that should be the position, is equal to octopus's x plus y times 10, and we're just going to do that, store that up here, like this. And that is going to be that dot ord plus 1, and then turn that back into a character. So ord gets the number of the, like the ASCII code point. CHR turns that back into an ASCII character. Those should be more or less free. They're just like type conversions. Right, and then I'm gonna do if octopuses at index is equal to okay, so we actually have to go, if you look at the ASCII table, why does everything use cookies? Cookie details, turn off these, save. So after a 9 in the ASCII table comes a colon, so we can do that. If it's equal to a colon, then octopuses at the index is going to be equal to 0. And now, so this is interesting because actually do that afterwards, because we want to make sure that, so in this example, for example, in here, we can see that when this, like we're going through this like this, so all these get turned into 2s, that turns into a 2, this turns into a colon and flashes, but after all of the flashing, this is still going to be a 0. So we need to somehow store that this should be a 0 no matter the sort of flashing. So we need to have a already flashed, which is just a bit set of the positions here are going to go up to 100, so we should be fine with a uint 8. And then we say already flashed, include the index that we're at, and then call add energy at position x minus 1 y with our already flashed set, and then x plus 1, and then x minus 1, y minus 1. Okay, let's do these in sort of in order. So this is the top right, top middle. Oh, I guess that's top right. And then left, we're obviously not going to do it to ourselves again. So that one. And then x minus 1, y plus 1. X and y plus 1. Already flashed here obviously needs to be a variable, so that this actually mutates the value that we're passed in. Read. Oh, it's not called read data, it's called read file. There we go. Octopuses. Man, I apparently struggle hard with that word. Octopus at an index. Oh, it should just be equal to a 0. Already flashed. Includes. This turns into a uint8 there, and this of course just needs to get an empty set. Ah, come on, it's not able to upconvert an empty set to I'm just gonna do this. It apparently wasn't able to upconvert an empty set to what? Oh, come on. Right, so it complained that my set wasn't good enough. But this is fine, I guess, because we need to be able to count these afterwards anyways. So we can do this, and then we pass in the flashed. Then we can echo out flashed dot cardinality, so the size of those that flashed this round. Right. So this, of course, should now, if index not in already flashed, because that means that we don't want to increase the power of it. Of course, that is, I mean, all of this could be done like that as well. Or actually we could do, if index is in already flashed, then just return early. Why doesn't it like that? Oh, index.uint8. There we go. We also need to check that these values are within our set. So if x is smaller than 1, or x is greater than 10, or y is smaller than 0, or y is greater than, oh, actually greater than 9. We also just want to return. Right. So then after one step, this should still return a 0. I'm not sure why that did so many steps. Oh, right, it did it. It echoed it out for every single position. So let's do actually just do flashes is equal to 0, and then flashes dot add, and then echo out the flashes at the end. Not dot add, plus equals. Oops. There we go. That should return 0. And if we echo out octopuses, not sure why it echoes it out like this. That is weird. But is this correct? 65942 65942 659, yep. 38569 38569 637566. Yeah, so that looks good. So now let's do let's run this for one more step. Now we should have some flashes. This have completely corrupted our inputs apparently, which is interesting. We have 34 registered flashes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So accounting for me counting wrong, 34 is probably correct. But our input was messed up. I think my indexing might be off here. But it seemed to work for step 1. Can you echo out octopuses? Yeah, because that echoes out fine. And then it broke it on step 2. So that turns this into that character. That should turn that into a 0. So for the first step, this should never trigger. But apparently, it must have miscalculated an index and messed up our input, which is interesting. I'm not quite sure how it managed to add this? Wait, no. This can't have CRLFs in it. Because what looks like is happening if we just do a single, oh no. If you do this, is that it almost appears as if it's breaking up a CRLF. So it does a new line, but not a line. Oh. You know what? It turns my line feed, like the new line character, into a vertical tab. I think. That's why we're seeing this, because it adds one to all of the characters in the thing. Which is weird because it shouldn't be allowed to go that far out. So I guess this is wrong. Well, it got a little bit less messed up in a way. Let's see. If x is smaller than 0, so if x is negative, or if x is 10 or more, that is 0, and that should then be 9. So if x is 10, this should just return. This should obviously be using index, which might explain why it was messed up, but it doesn't. So I'm guessing my math here is just wrong because it does these. So it does 0, 1, 2, 3, and then it comes all the way to 9, and then we have 9, 1, which should give us position 0, so 9, 10, which should give us an 11, if we've done this right. So that means 1 times 10 plus 1 is obviously not, or plus 0 is obviously not 11. There we go. That looks more correct. After one iteration, 385. 385, yeah. 637 it ends with. That looks good. If we throw in one extra iteration, we should now have 35, so that seems like I counted correctly. But there are a lot of 1s and 2s there, and those shouldn't be there. So after step 2, the first line should read 880, so that looks fine. But this area down here appears to have done like this 9, this 1 there should be a 0. So it looks like these are actually flashing themselves. So it includes my index into the set. And then it passes that in. So when it comes in, it's going to see that, that was already flashed. So I'm not going to do this one. Which means I'm not adding 1 to this. So somehow that index ended up not being in already flashed when that was called. I'm going to echo out already flashed. I have a feeling that it might not update. It actually looks like it does update. That is interesting. So it does look like it's always sort of growing. But what is going on with this then? There's a line, so it's on position 3, 0, 1, 2, 3, 4. So that should be index index 3 plus 0, 1, 2, 3, 4. So 4 times 11 plus 3. That is 47, and 47 is obviously in this. But another, if it's not this run, it will still count as being flashed. So we need to move the definition of this out into the iteration, not for this single position. So this should work. Yeah, so these at least look better. But this number is now way too high. Because it adds the flashes for every single one of those. So if you move that down to there, we now get the 35, and this looks correct. So if we now run it for the first 10 iterations, we should 204. What did it say? After step 10, there have been a total of 204 flashes, and it should look like this. So it should have a band of zeros there, and like big swaths of ones in the middle. That appears to be what we have, so that looks good. So if we now run this for 100 iterations, we should see 1,656 flashes. 1,656 flashes. That looks good. So if we now run this, we can just hide our octopuses, just output the flashes. Run this on our actual proper input and not the example input, and we should have the solution for part 1. Hooray! That's the right answer. So Craig Lobo asks, are you going to do it recursively? Yes, I'm doing it recursively, as you probably saw. So yeah, I'm just calling this add energy. This we could write in a nicer loop. This is pretty ugly. But as I said, I don't have a lot of time, so we're just gonna crack on to part 2 and see if we have time for that. Oh, not move it, copy it, and no. And then run part 2 just so that I have that in my history and don't mess up like yesterday. Continue to part 2. Okay. You've had the same problem and you don't know how to fix it. I'm not sure what problem that was because I wasn't reading the chat at the moment. I guess you might be referring to the staggering thing. Either to the staggering thing, which is solved by calculating the indexes properly and not adding to the new line character, or possibly this problem, which is solved by just moving that, moving this out to the step loop. Right, part 2. It seems like the individual flashes aren't bright enough to navigate. However, you might have a better option. The flashes seem to be synchronizing. In the above example, the first time all octopuses flash simultaneously is step 195. Boom! If you calculate the exact moments when the octopuses will all flash simultaneously, you should be able to navigate through the cavern. What is the first step during which all octopuses flash? Right, so if we now, for part 2, don't count the flashes, we turn this into a while, I guess we turn this into a while true, and we can say if flashed.card is equal to 100, which means that all of them flashed. We can break out. We of course need to know the iteration that we're on. So we're going to do this, and we're going to do this. And does that count 0 or from 0 or from 1, you think? I would think it counts the 0 step as, I think it counts the 0 step as like the initial position, but we should be able to test that by running it on our input example 195, which was the step from the example. If we now just run our code on our input set and hope that we don't have an insanely high one. Doesn't appear like it. 364 was the result I got, and that's the right answer. I think that's a new record for part 2. That took me what, like 10 seconds? Yeah. I'm not sure how would you have done part 1 in a way that meant that would be super hard to count. I don't know. But it was easy enough when we did it this way. If we actually sort these, we can maybe find a nice looping for them. The order of these shouldn't matter. So like the order of these shouldn't matter. We should still get the same results. So now we can do for yi in -1 ... do plus yi. That should give us the same thing. And we can do the same thing here, just call it xi. Oops. No. There. Oh no, actually it's yi still. It's always going to be yi. Yi-I-I-I-O. And of course that means we can combine these into one loop. We can also do this one in the same loop, but with a small addendum that if yi is not equal to 0, it's going to do this and do plus yi. There we go. Of course, this could also be a loop for xi in, well, we could do -1 or a count up from -1 to 1 with a step of 2. But I think the original there is probably a cleaner solution. Oh. This looks a bit wonky. It still gives the same results, so it works fine, but you know, this isn't super readable. Yeah. I think that is everything. What we could, of course, do is do this from a -1 to a 1. And then if xi equals x and yi equals I. Oh, you know what? We don't have to check this because it's in the already flashed. So it shouldn't matter if we call it one too many times. Since the first thing we do is check if it's in the set of stuff we've already flashed. And the first thing we do before this loop is to do this. We can safely call this with our current position because it's going to ignore it. I mean, it does mean an extra call, but the code is cleaner. So I think it's worth it. Yeah, that was part 2. Pretty simple once we had coded part 1 the way that we had. If you have written that in a different way, that made it hard to do part 2, I would be very interested in seeing how you did it. So if you have a different solution that made it hard to do part 2, because part 2 is typically harder than part 1, I would be very interested in seeing that. But yeah, it appears like we're going into the cave and we're heading down here and trying to find our way out from the cave down here. I'm guessing that we somehow get out, like back out to the seafloor here, or to the open sea back here. Yeah, that's again, as I said, I don't have a lot of time, so I actually have to leave now. But that's it for me today. Hope you're still enjoying Advent of Code, and hope you're still enjoying these streams. This one was a bit of a quick and dirty one. But yeah.